We think we know what a black hole is. It is the ultimate monster of the universe, a bottomless pit in space, a place where gravity becomes so strong that not even light can escape. For more than 100 years, this has been our story. A massive star dies, it collapses, a singularity forms, and an event horizon locks it away from the rest of the universe. Anything that crosses that line is gone forever. But there is a problem, a quiet, uncomfortable problem that physicists have whispered about for decades. The closer we look at the math of a black hole, the more it breaks. The equations predict a point of infinite density. In physics, infinity is usually a polite way of saying, we have no idea what is actually happening here. Nature hates infinities. Nature hates things that have no bottom. So in 2001, two physicists, Pavel Mazur and Emil Matola, asked a radical question. What if the collapse stops? What if the most famous objects in the universe are actually impostors? From the outside, they look like black holes. They have the same mass. They have the same gravity. They bend light in the exact same way. But on the inside, there is no hole. They called it a gravitational condensate star. Today, we simply call it a gravastar. To understand why a gravastar is so terrifying, you first have to understand what it fixes. Imagine blowing up a balloon. When you blow air inside, the pressure pushes out. The rubber skin pulls in. Eventually, you reach a perfect balance. The balloon holds its shape. A gravastar is essentially a cosmic balloon. Instead of collapsing into nothingness, the star's matter undergoes a violent phase transition. It transforms into a bubble of dark energy. This isn't science fiction. It's the same repulsive energy that is currently pushing our universe apart. Inside the core of a gravastar, gravity effectively reverses. It pushes outward. And what holds it together? A shell, an ultra-thin, ultra-dense skin of exotic matter. A physical barrier that replaces the event horizon. So mathematically, the hole is gone. Inside, there is a vacuum of repulsive energy. On the edge, there is an impenetrable shell. And outside, it looks exactly like a black hole, a perfect disguise, a bubble of exotic physics wearing the mask of a monster. This is where the story gets dark, because if black holes are actually gravastars, then our understanding of death in the cosmos is completely wrong. We are told that falling into a black hole is a quiet fate. You cross the horizon without noticing. You drift into the darkness, alive, until gravity eventually tears you apart. But with a gravastar, you don't fall in, you crash. Think of a lake. A black hole is like a drain in the middle of that lake. Water flows down forever. If you dive in, you just keep going. A gravastar is a frozen lake. From high above, the ice looks dark. It reflects the sky. It looks exactly like water. But if you jump from a bridge, expecting to splash into the depths, you hit the ice. If you were to fall toward a gravastar, you would accelerate to near the speed of light. You would expect to pass through the horizon. Instead, you would slam into the shell. This is not a soft landing. This is a collision with the hardest substance in the universe. So does this object actually exist? Or is it just a mathematical ghost? The terrifying truth is, we can't tell the difference yet. When we took the first image of a black hole, we saw a dark shadow surrounded by a ring of light. A gravastar would produce almost the exact same image. But there may be a way to hear them. When two black holes collide, they ring like a bell, sending gravitational waves across the universe. If they are true black holes, the sound should fade away cleanly. But if they are gravastars, the waves might bounce inside the shell. They would echo. Right now, scientists are combing through gravitational wave data, listening for these echoes in the dark. If we find them, it would be the biggest discovery in the history of physics. It would mean the universe doesn't allow holes. It only allows bubbles. Until then, we are left with an unsettling thought. When we look up at those dark patches in the night sky, we assume we are staring into endless pits of infinity. But we might be looking at hard surfaces, waiting for something to crash into them. You are here, and the universe might be a lot more solid than you think.